We are connected to the stream, guys. Welcome back to Coders Arcade, guys. Welcome back. Good evening, everyone. Welcome back to Coders Arcade. This is Ashank David, and in this live session, this is going to be our 22nd live session, and in this live session, we are gonna talk about today we will be finalizing and completing the trees concept, the binary trees concept, binary search trees concept. Tomorrow I will teach you a very new tree concept called as a Splay tree. So we will not waste much time into Splay tree, but I will just take one session on Splay tree. I'll teach three things about Splay tree: insertion, searching and the Splay options. We will talk about that later on. At the end of the class, I'll just tell you the logic behind it. But in today's class, let us give a final touch up to BST, the binary search tree class, and we will finish up this concept right away. Okay, so here we go. Before I start with this concept, guys, I would like to ask you people to please like, share and subscribe to our channel Coders Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Also, don't forget to share this stream as much as possible, because when you share this stream, a lot of people get to see about us, and YouTube algorithm also tries to push up into the content. And those people who really knows and who really want this DSA live session, they also can learn from it, and this is all for free. So please share this live stream as much as possible, and don't forget to follow us on Telegram and other social media platforms. The Telegram link is given in the description below. We are going to tell all the announcements related to placements or internships in our Telegram channel. Well, without any further ado, guys, we will start. Hello Mahesh, hi, how are you? Yeah, let us start our class. I hope so that you can hear my voice and you can see the board also very much clearly. If there is any issue or problem with the board or the font or visibility, do let me know, because I think that I am looking a little bit more brighter today. I need to change the ISO of the camera, but I hope so that everything, whatever I have written here is visible. Yes or no, guys? I hope so. If you have any issues, any problems, please do let me know. Today we will be finishing up the binary search tree concept, and today we will be finishing up the binary trees concept, and will be starting up with our Splay tree concept. I'll just give you a quick introduction to Splay tree concept, guys. So let us start. First of all, I need to explain you till now what we have done. Let's do a quick recap of what we have done, guys. Okay. So right here in the code which you are seeing right here, we have defined a class node, and we have defined all the things. This is the node class. We have created a binary search tree class, and we have created two things here: private section of the class and public section of the class. In the public section of the class, we have created all the functions which are publicly available in the main function to be accessed, and these are the functions which will actually get accessed and majorly working. On the other hand, we have the private section of the class, where all the functions which are working in an abstracted way, abstraction is getting applied here because it is object oriented programming, are getting implemented in the private section. Okay. So we had a lot of other functions also. So let us talk about some of the functions here. We have done till now three functions. We have done three functions. What are those three functions? In binary search tree, we have understood that it is a kind of a tree where the data which is smaller than the root is kept onto the left hand side, and the elements which are kept actually greater than the root node are kept onto the right hand side. So let us say if this is 100, so this is gonna be 50, this is gonna be 150. Same thing goes, same thing gets applied into their child also. So here also the node which is kept here will be smaller than its root node, which is 50 in this case. Let us say 30. This is, let us say 70. On the other hand, this is 130. On the other hand, this is 170. This is a binary search tree. Pranav Rai, hello sir, hi. Okay, so we have this as a binary search tree, BST. Binary search tree. Okay, BST. We have understood the concept of BST, and we have till now we have done three things. That is, insertion is done, then we have done the search function also, and also we have done the delete function also. Three things are done. Okay, these three things are done. Today we want to do our traversal and finish up this. Today we will do final traversal, okay, and we will finish up the concept. We did traversal in binary trees, now we will do traversal in binary search trees also today, and we will finish it off. Sir, I wanted to ask ये course कब over होगा? I wanted to make a schedule. So about this, Pranav Rai, my target to finish this course is gonna be this month. I'm trying my level best to finish up this course by the end of this month, because every day I am just coming live for 1 hour, and 1 hour will take up a lot of time. So I have eliminated doing live coding in this live session, but I have dedicated my most of the time to explain you the concept over the whiteboard or this blackboard, smartboard, and later on showing you the code and explaining the code which is already written here. So like this we are doing this course, and I am making sure that because we are doing the approach like this, you should know each and every line properly, and for that reason I am doing it like this. Now this is my first time I am exploring a course like this, and we really don't know at what exact time we will finish. Roughly I have taken the deadline as in this month we will be finishing it with graphs and dynamic programming, but it may take more time also, but it will not take more than the next month middle, that I can guarantee. Okay, Pranav Rai, what I want to say is that right now my deadline is till the end of this month, and I am trying my level best to finish it till this month, but I guarantee that it will not take more than the next month middle, around somewhere 10th or 12th, somewhat like that. So right now it is going on September, then comes October, so till around 5 to 10th October, or maybe 10 to 12th October, or 10 to 15th October roughly, we will be finishing up this course for your schedule. Hello Chandan Kumar Sharma, hi, hello everyone. So it's like that. So if you want to make a schedule, you can roughly make a schedule like that. I am running up the in-house batches also for DSA. So if anybody is interested in joining the in-house batch, you can join that as well. Okay, where I am doing the course in a confined time, where every day we will have 2 hours of class. So when I cover 2 hours of class every day, I will be able to cover that in a particular part of time, and that's how we do it. If you are interested in joining our in-house course, you can join our in-house course, where I will only teach the DSA part, but in a confined time. But this is totally free for everyone, and this is YouTube live, so I don't know actually when this is going to get covered, but our deadline is till the end of this month. Okay guys, let us continue now from where we left. So what we were doing, we were talking about the trees concept here, and we have finished up our binary trees, everything in binary trees. We have started with binary search trees, and till now in past 3 to 4 days we have done the insert, search, delete function properly, thoroughly. Understood this really well. Now, this is going to be, today's class is going to be the last class of binary search trees, where I will be covering the traversal part and we will be moving on to the next type of tree. Okay guys, and I need to push the button here for the camera, so apologies for that, you have to bear with it, because I am the only one operating the camera also and recording the same session as well on the live, so you have to bear with that. But anyways, let's continue. So here I have my tree and today we are gonna do traversal. Okay. Now let us say I am gonna copy this tree up so that later on I can use it for multiple purposes. We'll copy this and I am gonna paste it somewhere right over here. We are doing traversal, and traversal can be done in two ways, as we have understood really well. Traversal can be done in two ways that we have understood really well. Number one, BFS, which stands for breadth first search, and second called as DFS, which stands for depth first search. Depth first search and breadth first search. Speaking about breadth first search, you know this, that in any given tree, let us say you have this tree. If you wanted to do breadth first search, BFS, till now we have understood this really well. People who are constantly attending my class have understood this concept really well, that if I wanted to do breadth first search, this is a BST right here. The same concept is applied of what we have done it in binary trees, BT, and that was level order traversal. So we will traverse in this direction. Are you getting my point? We will travel in that direction. We will travel in that direction. Understood? And what I will do? I will directly print the element starting from the root. So say this is the root. This is the root. Okay guys? So in this case, the traversal would be 100. Then the traversal would be 50, then 150, and then 30, then 70, then 130, and then 170 would be our answer. This would be our traversal result. I hope so that this is very, very much clear. And how do we execute this? How do we write the code for it? We need queues concept, QUE queues concept. Let us try to do the breadth first search traversal for this tree right over here. This is your tree and we want to do breadth first search. Okay. Start by creating the queue. Let us say this is our queue. This is our queue. Okay. Let us say this is our queue. And in here I have taken the root index. Root is what? 100. So I said 100. And then I have started. So basically what I did is I said queue of type node star. I am using STL queues guys here. I have already explained this concept in a little in a very small and a very confined way in binary trees. If you don't remember the concept, I will explain you direct again. This is queues, STL queues, and here we were writing the queue name, and in the queue we were saying dot push, and we were pushing the root inside it, the root node, and then we were calling the while and we were starting the while function, while loop, where we were saying that not of, we were saying that not of queue dot empty function, which was checking if the queue is not empty. And what we were doing, we were taking out the front. So which is the front right now? 100 is the front, 100 is the front. We made the copy of it. So I said node star temp, and I said equals to, we will make a copy of it, of what? Queue dot front. Who is at the front? The root node is at the front. And as soon as we take out the front, I said that store it into the temp, and what do you do? You pop out. So queue dot pop. When you pop it out, this gets deleted, and then what do? You say cout, and you will print the not root but the temp, like that, temp of data, like this. You will keep on doing this and you will check. So this is popped out and this is also printed. Understood? Now you will check if it has left child or right child or not. So 50 is 100 is printed right away, okay, and then you will check if it has any left child or right child or not, okay. So how do you do that? You will check if temp of left is not equals to null, that means the left node is present. In that case, what do? You will say queue dot push root of left, like this. Continuously you do it. This is not root, but this is your temp of left. You got my point? Like this. Now same thing you will do it for the right hand side, and that will be updated in this case. So here what we will do, check for if the temp of right also is not equals to null. In that case, you will just say queue dot push temp of left, temp of right, sorry, right you will push, okay. Understand this, guys? So here you have, we have popped this out, we have printed this out. So 100 is printed, okay, 100 is printed over there. Now we are checking if the temp of left, that means this one, is it not empty? Yes, it is not empty, the node is present. In that case, push that left child in here. So you pushed 50, understood my point? And then you check for its right child also, if the temp of right is not null. Yes, it is not null, it is there. So you push that temp of right, and that temp of right gets pushed right over here. Understood this? And now rinse and repeat again the same while loop. Just keep on rinsing and repeating again and again. In that case, what do? The next front is taken out. The next front is 50. You see, make a copy of that front in the temp, and in the temp, and then pop it out, and then pop it out. After popping it out, you will print it out. So 50 is printed, and then what do? Check if 50 has its left child as not null or not. Yes, if it is not null, push that in. So 30 is pushed in, and then do it for the same thing for the right child as well. So 70 is pushed in, okay guys. Then this is also popped out. Now what is the next one? Next element is 150. So pop it out, take it out in the temp, pop it out. So we popped it out, print it out. So we popped it out, we printed it out. So 150 is also printed in the answer. And then check if 50 is left is not null. Yes, it is not null, it is present here. So add that into the queue. 130 is added, okay. and then check its right hand side. If it is not null, push that into the queue. So all these elements are pushed. Understood? And after that, what do? Take out the next front. Next front is 30. Pop it out, print it out. Pop it out, print it out. Pop it out, print it out. You will print it out in the answer. This is our answer. Okay guys, understood this really well. And our camera shut it down. We need to restart the camera again. And there we go. Okay, we are back guys. Let us continue. So we pop it out, we print it out, and then that is the answer right there. Okay, take out the next front. Do check if the 30 has left child or not. Left child is null, right child is null, nothing to do. Then come back. Take out the next front. Next front is 70. Pop that out, print it out. Pop it out, print it out. Pop it out, print it out. And then check if 70 has left or right child. There is no left and right child, so rinse and repeat. What is the next front? Next front is 130. Pop it out, print it out. Pop it out, print it out. Pop it out, print it out. And then come back. Check if left child is there or right child is there. There is no left or right child. So take out the next left. Pop it out, print it out. Pop it out, print it out. And then 170 is printed. Check if 170 has any left or right child. There is no left or right child. Hence, while loop will stop because the queue is now empty. And this is your answer. 100, 50, 150, 30, 70, 130, 170 is the right answer guys. This is going to be your BFS traversal of a binary search tree. The same exact thing what we have done previously guys, we are now doing it for binary search tree. For those people who missed this in binary trees can understand it from here. Now, if we move on to the code here, you see that we have done a small function here called as void BFS traversal, where the BFS helper function is getting called, because we have divided this whole program into two different parts, right? So BFS helper and BFS normal in the public section. Yes. So now in the private section we have BFS helper function. Now it's up to you, however, whichever approach you like, you try to write that in your way. But you see now, so in this case in the BFS we are passing the root, node root, because anyways we need to start from the actual main root. Okay, check if root is not equals to null. If the root is null, that means the tree is empty. There is no way you can traverse in the tree. So no problem, you just leave it, return it. Okay. Now in our case the root is not null, so we will continue here. What did we say? Create a queue first. So to create a queue, use this STL queues. How do we use the STL queues? We include the queues, hash include queues, like that, and then use it directly into our search function. Use it directly into our search function. Not search function, sorry, the BFS helper function. So in this case, after including that hash include queues, you say here queue. I'll just zoom it in a little bit. You see, after including that queues, hash include queues, you will say queue, and then in the angular bracket you will give the data type of what you want to store inside this queue. I know that I want to store the whole node itself, so the data type will be node star. Understood? So the node star will be the data type here, and then queues of type node star, and then the name of the queue will be given. In this case, the name of the queue is queue. Now, in the initial stages, what did we do? We pushed the root. So there we go. We will push the root. So queue dot push root. So first element is pushed, and then we start the while loop until the while loop is not empty. While loop keeps on running and running and running forever. So here we said I'll start by creating the copy of the root, so that when I delete the root, I still will be able to access its left and right child. So in that case, what I'll do is I'll make a copy of that front or queue dot front. I have already explained you what is dot front and what is dot back of the queue into our I don't remember the lecture number, but in our queues session, it would be, I guess, session number 5 or 6. Maybe it would be in session number 5 or 6, where I have explained you how queues work. Go and check out that session where I have explained you how queues data structure works. I have explained you the queues with the help of arrays, and also I have explained the queues with the help of linked list. There I have covered everything. Okay, but in this case, queue.front means the element which is going to get popped up, which is right now only 100, which is only the root node itself. So in this case, queue.front, make the copy of that node, and after you make the copy of that node, pop the root out, and using the copy of it, print its key. Understood a point? Print its value. So in this case, root is printed in the answer. This way the root is printed in the answer. Later on, using that temporary current variable, go to its left, check if it has not null or not. If it is not null, then push that left child into the queue, making queue again filled up. So this time the iteration will not stop and the while loop continues until finally all the nodes will be pushed into the queue. Understand the point? And here checking the right node also, right child also is equivalent to, very important, because this is level order. So first we will go to left, we will check and we will push, and then we will go to right, then we will check and then we will push. I hope so that this is very much clear to all of you, right? So we have checking that, and we are pushing it. Keep on doing this, rinse and repeat till your queue doesn't become empty, and one by one the next node comes, it is checked. If it is not null, it is not null. So the whole thing comes back inside the while loop. So again the next front is taken out, which is the root's left now, because root was popped out. So root's left is left. So left popped out, printed out, then left children's are pushed, then again go back, check with the right one, pop that right one, print that right one, check all the rights elements, and so on, it goes on like that. I hope so that this is very much clear. This is your BFS traversal of binary search tree. I hope so that this is very much clear. This is a very easy one and everyone have understood this very well. If you have any doubts, you can ask me and I will explain you there and there only. Apart from that, let us start with our another traversal, which is DFS. DFS, as I told you, is very easy to understand and very easy to implement. It is very small function. Let us start that right away. I hope so that this is very much clear to all of you. Okay guys, let's move on. So there we go. Okay, so now we need to do DFS, or depth first search, also called as DFS, onto this given tree. Guys, I have explained you DFS can be divided into three parts: pre-order DFS, in-order DFS, and post-order DFS. Pre-order, in-order and post-order. Pre-order, in-order and post-order. Okay. What happens in pre-order? Pre-order is left, pre-order is data, left and then right. In-order is left, data and then right. And then post-order means left, right and then data. Okay. You start from the root node. Let us say we are doing pre-order. Then you will write, what is pre-order? Data, left, right. You start from the root node, data, left and right. Access the data, cut that D. Access the data, print that data. Go towards its left, cut that left. I went to the left, you are here, DLR. Access the data, 50. Okay. Then go towards its left, which is here, DLR. Access the data. Access the data means 30. Then go towards its left. Now there is no left. Go towards its right. There is no right. Cut this. Come back. Now go towards its right. Went here. DLR. Access the data. Access the data. Go towards its left. There is no left. Go towards its right. There is no right. Come back. Data also done. Left also done. Right also done. Go back. Left is done. Left is done. And my camera is also done. So let us bring it back. And then which one is left? Right. Cut that right. Go towards right. Type DLR. Cut the data. Access the data. Access the data 150. Then go towards its left. I went towards its left. DLR. Cut the data. Access the data 130. Go towards its left. There is no left. Go towards its right. There is no right. Come back. Go towards its right now and DLR. Access the data. Access the data. Go towards its left. No left. No right. And our answer is 100, 50, 30, 70, 150, 130 and 170. I hope so that this is very much clear. Observe one thing here, that we are accessing the data first. Wherever we are standing, there the data is being accessed first. So whenever you access the data, you print the data in the answer. So as soon as you access the data, you print the data into the answer. So you accessed the data, you printed in the answer. Then you went to L. L means left. Cut that left. Again, as soon as you move on to another node, you again say data left, right. And then cut that data because data is accessed first. I hope so that this logic is very much clear. Those people who are new to this class and those people who have not understood the concept of DFS from me, now they have understood DFS from me. This is the easiest method to understand about DFS altogether. I hope so that this is very much clear about this. Alright guys, this is how you do it. Now if it is, so it was pre, remember guys, if it is pre, then data will be first. If it is in, data will be going to be in between. And if it is post, then the data would be at the last, at D. I hope so this is also clear. So now the same concept applies here, but you need to keep on doing either DLR or LDR or LRD. These three things, if you remember, you are able to do it directly. How you will code for it? Code is very easy to understand guys, very simple to understand guys. Let us see our code. Code is gonna be very simple guys, and this is our in order traversal we have written, but it is very simple guys. How to do? Let us see. You will check if the root is not equals to null. If the root is not equals to null, then only you can traversal. Do the traversal. If the root is null, then you will come out directly. I hope so that this is very much clear. So I said if root is not equals to null, then access the same data. Okay, one thing, not understand, I'll not explain you like this, not from here, but I'll explain you like this from here. This is a better place to actually explain you about this. No, not even here also. I'll take you towards the tree and I'll explain you there. This one. See, this is the best way to explain you. This is the best way to explain you. You see this. You see this. If the root is equals to null, if the root is equals to null, you will return, you will come out. Okay. Otherwise, go and access the root's data first. This is pre-order. This is pre-order. Access the data first. And then you call the same function again recursively. Same function you called again. When you called the same function again, what happened? This time you pass the root as its left child. Understand the point? It will check again with the new root value as its left child. Is the root null? No. So print the root's data. So it is on the root, printed the data, then you call the same function again with its left child. I hope so that this is very much clear. It's left child. And now the whole function is called again. So checking if the root is null or not, it is not null, it is present there. So what do? You print the data. Once you print the data, you will call the same function again for its own left child, like that. So all the left will be done with the data first. I hope so that this is very much clear to all of you. Okay guys, so in this case the data is accessed first, then the whole tree is like the whole function is called again for DFS. Clear? Once all the left recursive calls are over, then you start calling the same function for DFS recursively to its right child, and the job is done. Just 3 lines of code. Same thing we have done here also. If the root is not equals to null, we have called the same function first. This is in order, so data will be accessed in between, guys. Okay. So first go to left, recursively go to the left, and then access the data, then go towards its right. Understood? Like that. I hope so that this is very much clear. And this is your code for DFS, guys. I hope so that this is very much clear to all of you. And guys, we have finished up our binary search tree. The traversal also is done. Finally, we have come to the end of the binary search trees concept, and we have done till now in the trees, in the non-linear data structure in the trees, we have done 2 things, binary tree and binary search tree. I hope so that this is very much clear to all of you. Understood this? Finally, this is the whole code which we have written from the beginning till the end. I hope so that this is very much clear. Okay. Now, the whole code I'll provide you in the comment section below. I'll pin up the comment and I'll provide you the code also. Later on I will do that. But now it's before I leave from today's class. I want to tell you about something very much important. What are we going to learn in tomorrow's class? In tomorrow's class, we are going to start with, can you guess what we will start with in tomorrow's class? In tomorrow's class, what we will start with? Guys, in tomorrow's class, we will start with Splay trees. Yes. Binary tree is over. Binary search tree is over. We are going to start with Splay trees. It is also a very important data structure. It is a type of tree only, and I'll explain you the basic logic of a Splay tree right now. Splay tree. What exactly is a Splay tree? This is just a teaser for tomorrow's class which I am giving you right now. I am not going to explain you the whole concept of a Splay tree right now, but I am giving you just insight of what is a Splay tree. In tomorrow's session, I am going to cover up the Splay tree. I am not going to waste much time into these kind of concepts, but yes, I will cover this up so that it is there covered up into your syllabus. Right together we are doing it. So I'll start with the concept of Splay tree today, and this is just a teaser for what exactly is a Splay tree and what we are going to do in our tomorrow's session. Let us understand about what is a Splay tree. So this is a tree, guys. This is a tree, guys, and very familiar. Everyone has seen a lot of trees till now. correct? Let's say this is the tree and some values are kept 1, 2, 3, 4, 5, 6, 7. Some values are kept here. Now Splay tree means, let us say you accessed the element 6 from this tree. Let us say you accessed the element 6 from this tree. So this becomes the frequent accessed. Frequently accessed node. You guys, my camera went off. Let me just bring it back. Yep. Gonna finish up this class very soon, guys. Let us say this is the tree here which I have shown you. Now this is the element 6 which you want to access, and you have accessed also. You have accessed this. You have accessed this 6. After accessing the 6, this becomes the frequently accessed. So guys, in the Splay action, this whole tree, I'll keep it here. After you have accessed any element which is getting frequently accessed, you see, for example, here in this case, this was the original tree, and you have accessed this 6. You have accessed this 6. Then what will happen is that Splay action will be done on this tree once you have accessed any element. In that, what will happen there? The same tree, in the same tree, this was 1, this was 2, this was 3, this was 4, this was 5, this was 6, this was 7, right? You accessed this 6. So this became 6 became the frequently accessed. After doing Splay, what happens is that this 6 will go, up right there on one's place, and 1 will be brought down. So 6 will take up the position of 1. Understood my point? 6 will be taking the position of 1. Every single time you access the element, the frequently accessed element will be placed onto the root. Okay? Now, this is not exactly what I have explained you. The real logic behind this I will explain you in tomorrow's class. I hope so that this is very much clear. And this was just a teaser for a Splay tree. Now this has become the frequently accessed, so this element will come on the top because this was frequently accessed node, came on the root of the tree. Why this happens? So that we can access the elements really fast, because it is on the root, and access the element from the root can be really fast. It's so much fast that the time complexity to access the element is going to be O of 1. That is the imaginary case or the best case. That is the reason why we use a Splay tree, guys. So whenever you want to access any element which is getting frequently accessed, that element will appear on the top. So every single time if you want to access the same element, you don't have to access it, or you don't have to traverse the tree again and again that many number of times. That is what a Splay tree does. I hope so that this is very much clear to all of you. If you have any doubts, please do let me know. Now let us start our doubt session class, and let us continue this concept in tomorrow's class. So tomorrow's concept will be Splay tree, guys, where I will be explaining you how to do Splay trees. Implementation of Splay trees, understanding and logic building for Splay trees will be tomorrow's concept, guys. So stay tuned if you want to learn Splay trees. This is a very important concept. So we'll see that in tomorrow's class. On the other hand, if you have any doubts, please do let me know. I have started up the doubt sessions doubt session class. Let us start our doubt session. If you have any doubts, please do let me know. हाँ, each iteration में tree change होगा. हाँ, महेश, in each iteration the tree will change. Yes, that is your Splay tree. Apart from that, anybody has any other doubts? Mahesh, all your doubts are cleared, or you still have any doubts? Please ask. Any other question which you would like to ask? Because today there is not much crowd here, but let us see. Each iteration में यहाँ पे ट्री चेंज होगा, बिल्कुल होगा. देखो कल हम लोग इसमें एक पढ़ेंगे फंक्शन zigzag. We will learn about zigzag function tomorrow. In this zigzag function, every time you are going to do anything, the swap will happen. तो जब भी आप इसमें कुछ भी करोगे स्वैप होएगा, और जैसे ही स्वैप होगा उसमें पूरा ट्री बदल जाएगा, फिर से आपको बनाना पड़ेगा उसमें. तो उसमें आप रिकर्सिव कॉल लगाओगे. In this case, whenever you access the element, the tree will change again and again, and as soon as the tree change again, you recursively call the Splay function and it will keep on doing the function until the tree is set to its position in a particular order. I hope so that this is very much clear. So this was the teaser for tomorrow's class. So don't forget to attend tomorrow's class. Tomorrow's class is a very important class on a new topic of tree, Splay tree, and we will finish this up in no time. My target is to finish this Splay tree tomorrow itself, because we know we have done two trees, binary trees and binary search trees. Based off of the same coding style, we will be coding for Splay tree also. Apart from this, anybody has any other doubts? You can ask. Any other doubts? You can definitely ask. If not, then we can close up this session. I hope so that today's classes was understood. Then let us end up this session, guys. I thank you so much for watching this session till the end of this live. I will provide the code and I will provide the notes for this into the description below. I'll attach the notes, as well as I'll attach the note into our Telegram channel also. So do not forget to like, share and subscribe to our channel, as well as don't forget to follow us on Telegram, guys. I hope so that this is very much clear. Very soon we are working on our placements, as I have told you. So follow us on Telegram if you have not followed us yet. There we'll keep on posting up all the study materials, link to the important videos and whatever information related to anything. Also, if you want to do the same course in a very depth way, but in a very fast way, in a confined time, you can join our Coders Arcade courses. And that is what I just wanted to explain you in today's class, guys. Thank you so much again for watching this live session, guys. And the time is over. All your doubts are also cleared. So I'll be ending up this session, guys. Thank you so much. I will see you tomorrow again at the same time, 7 o'clock Indian Standard Time. I'll be back here with the new concept, with the new day. The concept will be Splay tree. You already know. So do not miss tomorrow's class. And that's all from my side, guys. Thank you so much for watching. This is Ashank David signing off, and I'm gonna end this stream right here. Thank you, guys. Thank you so much. Bye bye. Take care. I'll see you tomorrow.